Welcome. In this next section, we're going to look at further applications of trigonometry, and we're going to revisit the trigonometric definitions using right triangles. So when we talk about trig, we know we have various different definitions, and one of those was a right triangle. But then also connected to right triangles, we have other tools available, such as the Pythagorean theorem and also the angle sum rule, just meaning that all angles have to sum to 180. Okay, so I'm just going to write that: all angles sum to 180 degrees. Okay, so now we're going to turn our attention to solving right triangles, where we're given very little information. Okay, so we want, and when we say solve, it's find all missing side lengths and angles. Okay, and also just for all of our common understanding, when we set up a right triangle, oftentimes there's just going to be some information given to us, like angle A, side B, that sort of thing. And generally we're going to assume that angle C is the right angle, and then the side opposite of C is the hypotenuse. From there, we don't really care about A and B as long as we know which one is the right angle and which one is the hypotenuse. Okay, but the convention here is to follow a triangle, something like this. Okay, so we want to solve a right triangle with side length A being 10 and angle B being 22 degrees. So I'm going to set up a little diagram. So here's my triangle, and I'm going to say this is C, this is B, and this is A. And then I know side A is 10, so that's going to be the side length across from angle A. Okay, and then I know B is 22 degrees. Okay, so then C is, without, I guess, doesn't need to be stated that it is 90 degrees, because that's by definition here. Okay, but if I were to solve this, I need to find angle A, right? Side C and side B. Okay, well, let's find angle A first. Angle A for me is going to be the easiest, just because I can say that this is equal to 180 degrees minus 90 degrees minus 22 degrees. Okay, and if I do my mental math correctly here, I believe I should get 68. Okay, and so that should be the angle that I get. Yep. And now to find angle or side lengths B and C. How do I do this? Well, I can't use the Pythagorean theorem because I have two unknowns in there, right? I have two unknown sides. So I'm left with thinking about this a while, and then I'm like, oh, this is in the trig section. I should probably use a trig function. For me, let's maybe focus on finding side length C first. If I do that, I can relate 10, 22, and C via cosine. So I can set up cosine of 22 degrees is equal to C over 10. Other way around, 10 over C, adjacent over hypotenuse. Okay, and then I can solve for C, cross multiply if you want, or solve it any other way that you know how, but C would be 10 over cosine of 22 degrees. Okay, and for this, it would probably be easiest just to punch this in a calculator and see what you get. I got, let's see, 10 divided by cosine 22, and I got about 10.8 if I round to one decimal place, and that's generally the level of specificity that we need in this course. So if it doesn't say, you can ask. That's always a good thing. Otherwise, generally, if I'm picky about some number of decimal places, I'll tell you. Otherwise, just go with 1. Okay, so 10.8. And then lastly, for A, you can do this any which way you want. You have two sides now, so you can use the Pythagorean theorem if you want, or I'm just going to do sine. So I'm going to say sine of 22 is equal to B over C. B over C and C we found to be about 10.8. I will be a little off here just because I rounded 10.8, but it doesn't matter that much. When I solve this, I get that B is approximately, so 10.8 times sine of 22 now, 4.0 if I round. Okay, so about 4, and I will have solved the triangle. Okay, because I found all the missing sides and the missing angle. Okay, so that's how you can solve a right triangle. And the other type of thing we could see is something like this, where if we draw this now, CBA, right angle, A is going to be 33, C is 65. I have now two unknown angles and a side length B. Okay, so I want you to pause the video, see if you can do this on your own, and then resume the video when you're ready to see the solution. And here's my solution. Okay, to find the other side length, it's super easy. Just use the Pythagorean theorem right away. So that's what I did. If you, again, you could have a different way of solving it and get the same thing. Perfectly okay with me. Now for the angles, that's a little bit of a trickier story because you don't know two of them, and so you have to use one as unknown and find it using an inverse trig function. I found A here first via an inverse sine. You could have found B first via inverse cosine, something like that, but I ended up getting that A is approximately 30.5 degrees once you round, and then consequently just using the triangle sum property for B, you just find out that that's 59.5. Again, you could have set up an inverse trig function for B as well. All right, but that's just another quick example of how you can solve a right triangle with very little information.